Hi there. Welcome to section 7.3b. 7.3b, we're going to still use those rational exponents, those fraction exponents, or exponents that have x's, variables in them, and we're going to solve equations. So notice the first thing that we need to talk about is an exponential equation, which is an equation in which the variables are in the exponents. Looks very strange, so we might have something like 7 to the x equals 243, or other strange looking ones if you look at the examples. But notice our variable is an exponent. It's not 7 times x equals 243, it's 7 to the x power. So our variable is an exponent. So let's talk about what to do with these guys. First of all, we need to know about the power property of equality. Here's what this says. If you make the bases the same value, you can solve the equation from the exponents. If you make the bases the same. So in that example that I just said, 7 to the x equals 243, I'll jot it down. 7 to the x equals 243. One of my bases is a 7. My other base is a 243. Those are not the same bases. But if we can figure out how to make them the same, we can solve an equation. Here's the technical part of the power property. It says if something to the x is equal to that same number to the y, then the exponents are equal. Exponents are equal. So I've got an example for you down here. If I've got 5 to the x equals 5 to the third power, first thing we're going to check, do the bases have the same value? What's my base on the left-hand side of the equation, 5 to the x power? Just a 5, right? What's my base on the other side? Just a 5. Since my bases are the same thing, I know that my exponents are equal, which means that x must be equal to 3. So it's all about looking at those bases, and we might have to do some work if they're not already equal like they were. So here's what we need to solve an exponential equation. Rewrite so you have common bases. Remember, common means the same. Rewrite the equation so you have common bases. Set your exponent equal to your exponent, and solve for the variable if necessary. That last one we didn't have to. We just knew that x equals 3. Another one that we do, we might have to. So if necessary, if there's an equation, solve it. Tell me what x equals. So that's the basis. Let's do a problem or two. Let's do 1 and 2. Number 1, it says 2 to the x equals 64. Well, I've got a base of 2 and I've got a base of 64, right? They are not the same. I cannot do anything yet. However, think about your larger number, 64 in this case. Could we write that as 2 to some power? I always figure out, can I take the smaller of the two bases and just change the other one? So 2 to the x equals 2 to something. We've just got to figure out what that something is. You might need to go to your calculator. You might need to start doing some timesing. 2 times 2 times 2. How many times do you have to multiply 2's until you get to 64? 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times another 2 is 64, right here. So I have got myself 1, 2, 3, 4, 5, 6 2's. So 2 to the 6th power is equal to 64. Check it on your calculator, make sure we got it right. When that's the case, we now have the same bases, right? We've got a 2 to the x equals 2 to the 6th. Once I've got the same bases, I can cross those guys out. Now I know that x is 6. Equation is solved. I get the right answer. Nice, right? So number 2, let's do the same thing. 3 to the x plus 1 equals 81. Well, I'm going to think about this 81 and figure out, can I write it as 3 to a power? So I'll leave the 3 to the x plus 1. And now I've got to think to myself, Why does that keep doing that? Now I've got to think to myself, how many 3's do I have to multiply in order to get 81? So I'm going to do the same thing. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. I've got myself an answer. How many 3's did I write down there to multiply? 3 to the 4th power. Oh my goodness. This is driving me crazy. Hold on. Here we go. I'm back. So now that we've got those common 3's, I can cross these guys out, solve myself an equation that is the exponent. So x plus 1 equals 4. I am certain from all of your work that you did first semester that you know how to solve that. Subtract 1, subtract 1. I know there's a lot of 3's in this problem, but if we put a 3 in for x, we will get ourselves a true statement for that equation. So really the hardest part is figuring out what to do for the exponent part of the problem. All right, so let's do, why don't we do number 5? 5 is a good one. It says 216 equals 6 to the 3x plus 2. Well, I'm going to leave the 6 to the 3x plus 2. But I'm going to think about that 216. That 216, oh my goodness, it did it again. That 216 can be written as 6 to a power. So I'm going to go on the bottom and I'm going to do the same work that I tried to do before. So 6 to something is equal to 216. So might need a calculator. 6 times 6 is 36 times another 6. I think that's 216. So how many 6's did I multiply together? So that means 6 to the 3rd equals 6 to the 3x plus 2. So I switched that 216 and wrote it as a 6 to a power. Now that I've got my common bases, I can cross those guys out, solve this equation. Is it okay to get a fraction as an answer? Sure, why not, right? Move that down. So I'm going to solve this. I'm going to minus 2. So 1 equals 3x. Divide both sides by 3 to get the x by itself. So I'm going to end up with a 1/3 for my answer. In other words, if I put a 1/3 in for that x and did the math, 6 to that power, I should get myself a 216. We're going to skip number 6 for now, but we'll talk about that one in class because that is a kind of intimidating one with those fractions in there, but we can still handle it. All right, so let's talk about this. According to the power property of equality, if 3 to the 4th power equals 3 to the x power, what does x have to be equal to? Hopefully you got that one down, no thinking. And do this practice problem. Solve 3 to the power of 3x plus 1 equals 81. In other words, I need to make that 81 into a 3 to a power. This one looks a lot like problem number 2, if you caught that. So go ahead and do those two. We'll see you next time, and we're going to work more on solving these equations. That's it for section 7.3b.